Welcome to HEC's Montreal Statistical Modeling. I'm your host, Leo Belzil. So this is a video about to illustrate an example of cluster data. So we're just going to introduce the motivation data and have a look quickly at some of the features. Okay, so we've looked at an example of longitudinal data in the previous chapter. Now we're going to look at cluster data. So the context is we have a large business and they're interested in knowing about workers' motivation. Okay, and that was measured through a questionnaire. There was three questions related to motivation, namely, I share several of the company's value, I feel loyal to the company, and I'm proud to tell people what company I work for. And then each of these questions is ranked on the Likert scale, ranging from strongly disagree, so lowest possible score 3 is bad, and strongly agree is 15. Okay, so if you score 5 on each. And these data come from a study published in the British Journal of Industrial Relationship. Okay, so they were interested in employee commitment and gender dissimilarity. So we have the following explanatory variable: the number of employees in the unit. Okay, so that's going to be the same for every person in the unit, in a department. The ID of the unit, so you can think of, okay, there's the people at HR, then there's the people at IT, and so on, and then we've just assigned them a label, so this is just a number, but the number is arbitrary. There's the ID of the employee, right? If there's 9 people in your group, there's person 1, 2, 3, 4, 5, 6, 7, 9, but that's also arbitrary. The number of years of service, sex, which is binary, men is 0, and women's 1. The age of the manager, that's a common manager for each unit, so that's going to be fixed. And finally, our response, which is the motivation score. Okay, and here the source of correlation is not time, but rather having a common department. Okay, so you could think the type of work, people who are low-qual jobs, boring, maybe less motivated, people who have a crappy manager, and so on. So there's multiple sources of sources of frictional things that could affect employees' motivation within a unit. So we think there could be correlation at that level. And what's different from the data we've previously looked at is that units have a different number of employees. So this is showing you some data for Unit 1. So Unit 1 has 9 employees with ID employee ranging from 1 to 9. Different number of years of service, 6 women and 6 men and 3 women. I'm going to get that right. And then you can see the motivation score, and they have a manager at age 40. So number of people working in a unit and age manager are fixed, and the others vary within unit. So here we have 100 groups in total with 1,016 observations. So that's much more variable. So on average, there's 10 people per group, but it can vary from, say, 3 to 25. So there's a lot more heterogeneity, and then that means also that we'll have a bit more restriction when it comes, for example, to within-group covariance models. Okay. So here the goal of the study was really to look at the impact of, say, sex, years of service, unit size, and so all of the explanatories. But we still want to include within-unit correlation. One tip to keep in mind is that time is great because it's ordered, but there's no ordering for people for cluster data. Okay, so this means the AR1 model and the heterogeneous version, that's a no-go because there's no ordering, right? So it doesn't make sense to say that person 1, has a correlation that's lower with person 9 than with person 4 because 4 and 1 are closer than 1 and 9. I mean, it makes no sense, right? The labels are arbitrary, therefore this is also meaningless. We had the unstructured model, unstructured covariance model, which here, if we had a group of size 25, really there's just going to be, first, we need to have more than one replicate more than one group of size 25, which I don't think is the case. And you need to have enough observations. So that's just too many parameters. There's more parameters than there's observation. Forget it. And we could also think of perhaps compound symmetry with heterogeneity, but then there's 25 marginal variance parameters. Forget it also. So there's really two models that are competing here. One is going to be compound symmetry, and the other is independence and homoscedastic errors. So we're going to go for the compound symmetry, and we'll see if it actually if there is a within unit correlation. Maybe there's not, but then we can test for that. And that means that if you're within a particular unit, the correlation is the same regardless of the person, and this exchangeability assumption, now that makes much more sense than in the time series context. So proc mix, I'm fitting using REML. This model, I have one categorical variable, which is the ID of the unit. Okay, the two fixed variable age manager and unit, these are continuous, and I fit repeated. So the subject is ID unit. I fit a compound symmetry, and I'm just going to print covariance and correlation for group 1, which has 9 individual. So here I'm just showing you the covariance, so you can see the conditional covariance parameter. This tau is 0.24, and we have something like 1.125 for the sigma square parameter. Okay, so the variance is sigma square plus tau, and so here that's 1.37, and that's what you see in this table. Okay, not necessarily telling you a lot. Perhaps it's easier in terms of correlation. So the correlation within unit is 0.17, which is relatively significant. And if you actually compare this compound symmetry model that has within group correlation to the independent homoscedastic model, well, there's overwhelming evidence, okay, based on the likelihood ratio statistic, that there is some correlation, and that the compound symmetry is a much better model. Okay, so the independence model is not an adequate simplification. 79 is much bigger than 3.84. We have the effect of the explanatory variable. So here, this is just like a linear regression model. The only difference with, say, the output of a linear regression model is that here you'll see that the degrees of freedom depend on the actual unique instances of the variable. So it's lower for, say, age of the manager than it is for years of service, because there's just more different years of service than there are number of manager, right? There's 100 units, 100 managers. We can see women are more motivated than men on average. So this 0.56, women have sex equals 1. So on average, they have 0.56 additional in terms of score on the 3 items. So for the sum, everything else being equal. Years of service is negative, so every additional year, your motivation drops down quite a bit. Okay, so the less they are motivated, everything else being equal again, and the older the manager, the more motivated. So again, this is still significant, but the effect is a bit smaller than for years of service. Okay, and there's a small effect of the number of people in the unit. So you can think that this is tiny, but if you multiply it, say, by 25, then it's a slightly bigger number. Okay. And same for age of manager if you actually multiply it by age. And age of the manager, probably manager cannot be less than 20, so this is kind of compensating for years of service. Okay. Though the size of the size of the unit is not statistically significant, so this is small, and it could also be 0. So we would be perhaps interested in knowing if there's discrepancy between units, if there are effects for the different units, but that's not going to fly here. So we've seen that if you do include those as covariates, well, you're going to lose the ability of estimating the coefficients for here age manager and n unit. So we'll have to wait in another video before we can actually do that together. So stay tuned.